Well, hello all. Today on the bench we have a Swan Cygnet. This is the model 270B. It's a 10 through 80 meter tube type transceiver, and this actually belongs to a local. When I say local, he's about 25-30 miles away, so not too far. He had a friend of his that found my YouTube channel and found out that I repaired these old boat anchors, so this guy contacted this owner and let him know, and he brought it over. And the complaint is no transmit output on this rig. And I can probably already tell you one of the reasons why the transmitter's probably going up. If you're not really familiar with tuning a radio of this type, this uses a sweep tube like used in televisions back in the day. Actually should have a 6LQ6 in it, which is many varieties of that tube. So if you don't tune it quickly, you will risk damaging the output tube. So what I want to do is just go ahead and get it checked out today, find out what we're going to have to do to get this old boat anchor back up and going. One of the first problems that I've seen is the meter is cloudy. You can barely see through the lens. That needs to be fixed. Not so that you can just see the meter, but where you can properly tune the carrier balance and bias settings the way it's supposed to be. If you can't see where the meter's at, you can't properly tune the bias and carrier. So what we're going to do, we're going to plug it up, warm it up for a few minutes, and just look at it to see if it will tune up and what type of problems we are having. So one of the first things that we'll do, now that I got the radio on and warmed up, make sure it's in the receive position. PA cathode switch is in the PA cathode position, not the S meter. We're on 20 meters, and I've connected an antenna up, and we're going to listen, and we're going to peak the drive, the plate load, for maximum noise. And this will get you somewhere close, because when you're peaking these for receiver, you're also setting the transmitter. So we'll turn the volume up. Peak it for maximum noise. You can hear it low as you come up with the PA load. It gets louder, and then it drops completely out. Same thing going on with the PA tune. And that tells me that there is probably some dirty grounds on the variable capacitors, so we'll need to get those cleaned up first. We're all going to have to address this meter. I think I have another meter that'll fit in this rig. I have to look around in my junk box to see if I can locate it, but I'm sure I have at least have a case, if not the whole meter. And I'm seeing all kinds of noise going on here. Look at the IFR. You can see that big plume across it. Also on the, if I can find the oscilloscope, see by moving the controls. But here's something interesting. Look at the spectrum analyzer as I rotate the PA load. You can see the signal come up right here, and then drops out, and there's a PA tune. Yeah, so it looks like we got a little bit of work cut out for us here. Probably the best thing to do, go ahead and crack it open, and we'll clean up some of these controls. We're going to have to again address this meter, see what we can do with it. Might be able to clean it and polish it, I'm not sure. It's very cloudy. And the biggest thing is check the 6LQ6 tube and see if it's any good at all. Now the quick and dirty method of tuning this rig, instead of going through what the manual says, is to just go ahead and peak everything watching a watt meter. Alright, we're looking here at the watt meter, and I'll go ahead and switch it to the tune position. And we're on the 20 watt scale. We'll peak the driver, peak the load, and peak the plate. And we got a whopping 30 watts out of it. So again, I don't know what the bias is. It looks like it's cut down real low. I cannot even see the meter to tell where that's at. But my bets are that either the driver and definitely the final is bad in this radio. We got the case off, and I want to take a look at this meter, and you can just see it is completely white. You can't even see through it. So I think what we're going to do is go ahead and remove the 2 wires from the back, pop this clip off, and get this meter out and take it apart. See if there's any way to bring a clear lens back to the front of it, because it's just impossible. I mean, it's almost solid white. Okay, I have the wires disconnected in these LEDs. Get them pulled on out of the way. And to get this meter out, all you do is take something to put behind this part of this tang here and just give it a little pull, and do that on both sides. Till you get this whole clip off. And we're able to pull the meter right out the front. And you can see just how bad it is. It's almost impossible. And if someone hasn't put too much glue on it, it looks like it's been really coated in some glue. I'll see if this meter will come apart. So I removed the 2 screws that hold the cover on, and luckily the meter came apart. I really don't want to, but I may have to remove the whole element, and you have to be very careful because there's some very fine wire, you can't hardly see it, that comes from the coil to both sides of these posts here, so you have to be real careful with that. But looking at this, it almost looks like somebody's just smeared glue all over this meter, and got it on the front. And the owner said that he's tried to polish it with several things, so I'm gonna look around and see if I got something that can help polish it. One thing, the last resort without replacing the meter, is using heat to heat this front, and sometimes that'll take the haze off and clear the meter back up. But we'll just look at several options and see what we can come up with. If not, we may just have to change out the whole meter. So as you see, I do have another meter, and this is actually out of a Siltronics. Now, I don't know if the coil is the same. You have to be careful putting a voltmeter on this, because you can damage the coil. If you wanted to check, you know, to see if the ohms were the same. I'm not able to read any lettering off of this meter since it's been covered in glue. but I'm sure there may be a difference. I'm not sure, but it's good, you know, good chance that it is. But if anything else, I can remove the coil out of this one and put, you know, swap them so that we'll have at least a good meter that we can use. But first we're going to try to repair this other one. So this is what we're going to do. I've tried several different things to clean it with, and nothing's happening. So what we're going to do is use some hot air and see if we can't bring this meter lens back to life. Now I will tell you, you got to be real careful, because this is a plastic material and you can burn it, and once you burn it, it's over with. Okay, so I try to set this up so you can see what's going on. So we'll turn the hot air back up and we'll have a go at it. It's looking a lot better already. I think we got a winner. You can see it took the frosting right out of it. Now what this is doing is just actually heating the outer edge of the lens and melting it all back together, and that's removing all those little imperfections, and it's coming out pretty good. And you can do this if you have some that has real fine scratches in it. Now I can take this and polish it more and see how it looks. But I think that took most of it out. At least now we can see through the lens. And you notice we didn't burn anything, and it's not bad. There's a couple of scratches in there, but we're not going to try to, you know, to go too far on it. But yeah, that cleaned it up real well. Now I think this meter will be usable. Well, there you go. The meter's back installed, and you can see we have a completely usable meter now. Now let me tell you, if you attempt to do this, you're doing so at your own risk. You know, too much heat and you'll warp it, you'll turn it brown, where you actually burn the lens. So you have to be real careful. This is, you know, just a hard plastic. It's clear acrylic. Anything that's clear like this also work on you know, some of your meter facing and some of your radios, it gets little micro scratches in it. The hot air will take it out. Again, be very careful doing it, because you can go from something that don't look good to something that's totally useless. And if you want to practice on it, find your old CB radio, pull the S meter out of it and practice on that. That way you can get a feel for how much heat you need, you know, to put on it, and how long you need to put on it. I mean, this, you just swipe it across it. I was running at about 850 degrees Fahrenheit on the heat gun to get this fog off this meter. So yeah, it turned out pretty well. Now we can use the meter to test out the radio with when we go to do some adjustments on it. I went ahead and pulled the tube that was in the final, and it was a 6ME6, and I put it on the tester and it tested just about 10%. It was completely dead. It's got some scorch marks in it. You can see this brown haze is around together, and there's several burnt spots in the tube. So this tube is kaput. I put a new 6LQ6 in from my old stock, and I just wanted to check now to see if that made any difference on receive. And you can still see the receive goes in and out as you rotate, and not the way it normally should do. It almost sounds like the plates are scraping. So I got a good look at the plates here on the tune control, and they are not touching. So you can hear, just by rotating that and looking at the IFR, you can hear it from the IFR. It's going into oscillation. So it sounds like to me that the capacitor may be loose in its ground. I went ahead and cleaned out these the ground on the tuning capacitors and lubed them up like they're supposed to be. Now we'll turn the volume back up. And as you can hear, we definitely have a good peak for the receiver, and no more of that scratching and popping. And even looking at the spectrum analyzer, you can see now there's no oscillation in the circuit. And it was almost like the bias was turned way up on this thing, making the final PA section go into self-oscillation. You probably would do the same thing if you turned the volume all the way, the bias all the way up. It would make the PA go into a self-oscillation because you're biasing the tube so hard. But that seems to have taken care of that problem. Okay, with the capacitors clean and a new PA tube installed, the rig now has full output. And when I key the microphone, we can get our bias adjustment set correctly. However, keying the microphone also causes another problem. Excuse me for holding the camera. When I key the mic, we now have full output, and also the carrier balance has no effect. I'm not able to null out anything, so there's something still oscillating in the radio. This time it's probably best to go ahead and order all new caps, check out the rest of the tubes, and look the unit over real good and see if we can find any mistakes or problems that could be causing it to go into self-oscillation. Even with the receiver on, we can key the mic. You can hear that squeal in the background, and that's what the mic gain turned all the way down. So yeah, something's still oscillating, and it's causing a problem. I'll go through the neutralization on it and see if that helps fix anything. Okay, I went through the neutralization process. I didn't show that on camera, but I went ahead and checked that, and we got that right, so that's fine. I'll show that later once we get the other problems. But I feel like we need to go to the balance modulator and start troubleshooting around that. You know, still without replacing the caps first, we could be just chasing our tail on this. So we get the caps placed, and then we can go ahead and start troubleshooting, and we'll know that it's not something being caused from faulty capacitors. So the radio of this age, there's no need of going in here and checking any capacitors. It's just best to go ahead and take them out, replace them. Yes, they could check good, but still, you know, these capacitors are old. And as you can see, we got quite a few over here. Over here on the board, you see these big electrolytics here. Then there's a couple of small ones over here, and one or two throughout the radio. There's a big can capacitor up here. So what we'll try to do is get those capacitors mounted somewhere out of the way, and get them wired in underneath. But yes, capacitors and then resistors. So what I'm going to do is go ahead and loosen up these nuts on this board, and pull this board out and go ahead and replace these electrolytics. And just to show you what I'm talking about, we'll look at this capacitor here. You can see it's already oozing out the vent hole here. So all those has got to go. Okay, now that I got the two nuts off the board, I'm able to raise it up a little bit and get this clip out of the board up under the clip. So now I'm going to go ahead and replace these 4 caps with some new ones. And usually when I install caps like these 100 at 350s, I always like to put them so that the writing is up, and this way when the next person goes to do it, he can look right at the cap and see what it is. Doesn't have to rotate it or find out or desolder it to find out what it is before he orders that capacitors. Just makes for a neater install, you know, and helps the next technician down the road. So I'm going to go ahead and get these unsoldered and get the new caps in. On the back of this board, it's real hard to get to without unsoldering all these wires. There's a bunch of little resistors back there, and we'll have to test those. There's also some diodes back here, and I'll go ahead and get them checked. Alrighty, I'm going to haul these old dinosaur caps out. Got new caps on our high voltage, our medium voltage supply. We got new caps over here in our negative voltage supply. And now I guess I'll go ahead and move on and see what I'm going to do about this can capacitor and go ahead and get those replaced. Okay, now I got to get this can capacitor replaced. And we can see over here, we zoom in on this a little bit. You can see right here under this leg, this has the square symbol, so that's a 80 microfarad at 400 volts. You can see what's leaking around this leg already. So we know this capacitor is definitely bad. Again, no need of changing them, just or no need of checking them. Just snatch them out, replace them, be done with it. Alright guys, the can capacitor here has been removed. We had two 80s at 400 and two 5 microfarads at 400. Mounted the two 5 microfarads at 400 over here next to the circuits where the wire was going, so it did right with the leads. Mounted a little small circuit board here up here on the other circuit board, and just bolted that down, and then run the 280 microfarad caps to there, and then down here to ground. So that takes care of all the electrolytic capacitors. One thing I was worried about was these big resistors over here putting out a lot of heat. It's never good to have electrolytics close to anything putting out heat. So the electrolytics are down further to the bottom of the radio, so the heat should rise up and shouldn't affect these electrolytics at all. Since you know, the radio is upside down and these resistors are closer to the chassis than what the capacitors are. Okay, I was going to start testing on the transmitter, and I went ahead and pulled the old tube out because we know it had no output. And I had stuck a replacement tube in there like I always do before I put the new replacement in. And we had full carrier on single sideband. You know how these Swans work. When you tune them up, you got a carrier control, and what you do, you rotate the carrier control until you have minimum meter reading. And this one is showing 100 watts. It doesn't matter where you set the carrier control or the carrier balance. A couple of things do bother me here on this. First thing I noticed is that the carrier balance control, if you notice a little white dot, only on the bottom, and the set screws on the top. And if I remove the knob, you can see the flat here is on the top. So I can't change the knob around to have it where it's supposed to be. Now this tells me that somewhere in the past someone's had this control out, or they've replaced it with another control. Now if it wasn't so profound where it's putting out 100 watts, you know, and you could tune it some, I would say it's in the neutralization. But since this has no control whatsoever, you know, your problem could be in the 6JH8 or the control underneath of it, or a capacitor or resistor in this stage is gone bad. So what I'm going to do is put another tube in it and try it and see if that's it. Maybe my tube has a issue I'm not knowing about or can't see on the tube tester. And then we'll check this out. And if carrier control still doesn't work, then we're going to have to start going into the carrier balance circuit and see if we find out what's going on. Well guys, I want to start tracking down the carrier balance issue. I can't find nothing in the PA that could be causing any problems. So if we look right here in this part of the schematic, we can see our 6JH8 balance modulator tube, and right over here is our carrier balance control. And according to this, it's R1307. It should be a 5K control. There's also a resistor coming off of one end. Resistor here. I've already checked these resistors. They're looking good. I come over here and I check the voltages, and pin 1 should have like 45 volts on transmit and 0 on receive, and I'm only showing about 3 volts on transmit. That's not really nothing I'm concerned about. But what I am concerned about is this part here. Like I say, you know, there's something funny about that part that was in there to start with. I went ahead and desoldered the wires and the resistor that took it to ground, and I'll go ahead and I've got the ohm scale on 20K. We'll check this side of the part, and I'm showing 5K from there and then down to 0. Okay, right. Not really. If I go to the other leg, that should automatically jump up to 5K. I'm turning the part, nothing is happening. And if we go completely across the part, we should read 5K. And we're reading nothing. So it looks like we may have found our problem. It's right here in this balance control. So I'm going to have to dig that thing out. Unfortunately, it's just not easy to pop out. Got to take all the knobs off the front because this thing is sandwiched down in there. Okay guys, got the new carrier balance part installed. And we want to just go through a basic tune-up right quick. First thing we want to do is just leave the radio in receive mode. I've already pre-tuned it, but we'll go through it again. We want to set our idle current. You see a little triangle right here. That's for 60 mils. And I got that adjusted dead on 60 mils. Now we're just going to go to tune. Peak the tune driver. Driver's peaked. We'll go ahead and peak the tune. Dip the plate. Alright, got the plate dipped. We'll retune it again. That looks good. We dip the plate a little bit. Look at the watt meter. Test 1, 2. 1, 2. Yep, it's looking good. Now what we're going to do is go ahead and check the neutralization of this tube. Okay, we're going to take the PA load control. We're going to turn it to the 9 o'clock position. The knob is off. I do need to reset that. But 9 o'clock position will be fully counterclockwise. And I can't stand it like that anyway, so let's go ahead and change it. It's that simple. Okay, we're in the 9 o'clock position. We're going to cut the mic gain down. I'll key the mic. I'm going to bring the carrier up to about 100 milliamps. We'll get back up and peak the driver again. Bring this back down to 100 milliamps. That won't go over 100 milliamps. So to neutralize, what we're going to do, we're going to key the mic. We're going to rotate the PA load from the 9 o'clock position to the 3 o'clock position. I'm going to watch the meter over here. And I do not want the meter to go over 100, but I do want to see a dip through that range. And there's my dip. Okay, I got just a little bit over 100 milliamps, so I'm going to come right here to the neutralization capacitor here. And we're going to just get that so that that range is down below 100 milliamps. And there we go. There's my dip. And that looks good. So now we can key it up. We can turn this back to minimum. And there's no dead key on the watt meter. So see, it's very easy to neutralize these. It's not no problem at all. Like I say, you know, you bring the PA all the way to 9 o'clock. Make sure that when you rotate, by keying the microphone, when you rotate from 9 o'clock to 3 o'clock, that you do not get a plateau or a maximum peak over 100 milliamps idle current. If you do, you stop, you tune the neutralization capacitor so that this meter falls, but you know, to 100 milliamp, and then you go on, just go on through the whole range. As long as you don't go above 100 milliamps, you're fine on that neutralization. Now all I'm gonna do is set the VFO, and if we turn the calibrator on, there's the calibrator there. I will advance the carrier balance. That way I'll have a little bit of carrier. That's kind of like giving it AM, and I'll look at my frequency error meter. Go over here to 10K on the, and we're about 6 kcs off. We should be able to bring it right back up to 0 with the dial set. Now I can readjust my dial set since I had it off earlier. I had to take it off to get that front panel back far enough to change out the carrier balance part. Yeah, we're dead nuts on frequency. So having a little trouble on 40 meters. You hear the noise from the receiver through all the bands. It's pretty good. When you go to 40 meters, it's dead. You can wiggle it and get it to come in, but it won't come in good. Now I done sprayed the switches down here and went ahead and cleaned this. I'm gonna have to go in this VFO and clean this wafer switch inside. Okay, so everything's all tuned up, looking good on the watt meter. Something I got to do, I got to move my watt meter from up on the top shelf down here so I can have my watt meter in view of the radio. That's something I need to do. So what I'll do, I'll just go handheld here for a second. Right. Then we'll get the tune. See, that's looking real good in the tune. Remember, when you go to tune, that's about half of the voltage, so it doesn't do quite as much. Check 1 2, radio check 1 2, test 1 2 3 4. She's bumping about 85 to 90 watts output. Not bad at all. And we can see our meter now. When we key the mic, we're right on to 60 mils. We'll go to tune. Go to our driver. Make sure that's peaked. Plate's dipped. Just to load for max. Redip the plate. Looks good. Yep, full power out.
Well, thank you very much, you too. This is Whiskey 3, Mike, QRZ. Kilo Mike 4, Yankee Mike India. Kilo Mike 4, Yankee Mike India. Thanks. 1 Hotel, Mike Delta Charlie. QSL? QSL, Georgia. 1 Hotel, Georgia. QSL? QSL, thank you very much, and good luck. Whiskey 3, Mike, QRZ.
Kilo Charlie 4, United Mike Oscar.
Delta Charlie Radio, 1 Hotel, Mike Delta Charlie. QSL. Okay, thank you for Kentucky and good luck. There was a station with a United in there. Your full call?
Kilo Charlie 4, United Mike Oscar.
Okay, there's two of you in there. So the 9 United, please stand by. This is Kilo Golf 4. Kilo Golf 4, your full call? Kilo Golf 4, what is your full call? Okay, must have misheard it. It's 9 United, your full call? Yeah, Norway Juliet 9 United, thanks for your patience. 1 Hotel, Mike Delta Charlie, QSL. Okay, thank you for the 1 Hotel Indiana, and good luck. This is Whiskey 3 Mike. Was there another United station in there, please?
Kilo Charlie 4, United Mike Oscar.
Okay, there you are. Kilo Charlie 4, United Mike Oscar, thanks. 1 Hotel, Mike Delta Charlie, QSL.
You're 1 Hotel, North Carolina.
Alright, 1 Hotel, North Carolina, thank you and good luck. This is Whiskey 3 Mike. QRZ.
Not a bad little contact from Maryland there. Winterfield Day. Having a good time with this thing tonight out here on Winterfield Day. Well, the Swan Cygnet Model 270B is now back up and going. As you can see, it won't a lot of work to do to this. Mostly, you know, getting them old caps out and fixing the balance carrier and getting the meter so we can see through it. And, you know, not hard at all. It's a very easy old radio to repair. And that's why I like these old radios. They're easy to work on. They're fun to work on. It's nothing like these complicated solid state rigs of the day. About anybody can learn to work on something like this. You know, you just got to be careful because there's high voltages in here, and they can give, you know, make for a bad day. Anyway, I hope you enjoyed the video. I'm going to go ahead and end it here with that, because this is all we need to do to get this back up and running. Now we can get it back to the owner and let him get on here and work some 80 meters. So till the next time, we'll see you in the next video. Bye.